So welcome everyone to the Licentiate Defense of Ryan Ruvald. My name is Alessandro Bertoni. I'm Associate Professor here at the Department of Mechanical Engineering. I've been supervising Ryan during this journey to his licensate together with Christian Johansson this year, and just registering and streaming this presentation, and Andreas Larsson, who has actually been the main supervisor of Ryan. So today, Ryan is going to defend and present his thesis for about 25 minutes. After that, we have invited an opponent, which is Professor Åsa Eriksson from Luleå University of Technology. She will step in on the stage and ask some questions to Ryan, and hopefully get some interesting discussion around the topic that Ryan is going to present. And this will take more or less 50 minutes, 1 hour, depending a little bit of how many questions Åsa has. After that, we'll open the question time for the audience, so you actually are able to ask questions to Ryan. We aim to finish this around 2:30, more or less. I will try to keep the time for that, so 1 hour and a half from now. I don't spend more time. I leave Ryan on the stage. And you can start.
Okay. Thank you, Alessandro. Welcome, everybody. Thanks for taking time out of our days to be here and listen to me talk for a little while. Okay, so we're going to start with a little bit of context around where I've been working so we can get a better understanding as we narrow down to the specific results from what I've been doing the last 2 years. So, yeah. Okay. Well, if it ever comes back, it'll show you that we are living in very interesting times. There we go. And we have exploring a lot of new technologies that have become available to us. And they're becoming available in ways that are industrializable. So not that they're new and popular, but they are now able to be scaled up and used in a lot of different things. So we have electrification, we have autonomous vehicles coming up, we have IoT, and we have machine learning, and that's just to name a few. We have 5G, global Wi-Fi, all sorts of these things are very exciting. And what they're doing is opening up the design possibilities for us to create solutions that are beyond just the typical products that we've seen. And so we have the ability to do transformative innovation. And so what we've been seeing a lot up to this point is, and not even just this point, but a lot of work is around incremental innovation when we talk about innovation. We are making individual products slightly better and just trying to improve and maximize the effect of one product. But what we want to do is look towards solutions, complete solutions that are an entirely new mountain that we need to climb, but they will have potentially a much higher value, depending on however we want to measure that value, be it efficiency, productivity, or safety. And when we get to these sorts of new types of solutions, they can no longer be serviced by a purely product sales model. So we look here towards product service systems, where in the book on the left we have pure products, which is what we mostly deal with on a day-to-day basis. You buy something, you own it, you get rid of it. And then we look on the far right, you have pure service, where you don't own any of it. Say a taxi ride, where you get in the car, you get out of the car, you pay to be transported, and that's about it. What we look at is something along these. So you have an old product, and typically the way I like to discuss the PSS as an example is there was Rolls-Royce, which started doing this back in the 50s, was the first ones to do this concept called power by the hour. So traditionally, in an engine manufacturer, they would sell the engine to Boeing or whomever, and then Boeing would take the plane and then sell it to the airlines. So then the airlines would own and operate the plane and buy parts and buy services, but not as a total package. So what they started to do instead was to move on towards what they call power by the hour. So instead of selling the concept of an engine, you're selling the power of thrust and the availability of thrust to propel this machine and propel the business forward, which is providing them with much more planning and capability of understanding that their operations can be secured and continue to run on a regular basis. So we then move into this new era where you're developing an engine that Boeing or Rolls-Royce will own and then continue to sell the thrust. So it's in their best interest to
optimize and continuously improve this machine beyond just incrementally, because they need to be responsible for the ownership of it and how to actually make sure that it provides the thrust and what they've sold to the provider. And then, so when we're doing that, when you're trying to design a product service system, you have a little bit of a different challenge. When we're talking about innovation, this is just an example where there's the 10 types of innovation. And you have our current, if you work with purely a product, you're working on pure product design. So although a pure product will say a car still incorporates a variety of different disciplines and perspectives, be it mechanical engineers, the thermodynamics engineers, aerodynamics, there's plenty of different perspectives, but in essence, there's still quite a narrow group of people that need to collaborate in order to create this pure product. And when we talk about product service system design, you're then trying to convey and design this broad entire solution. So you're not just thinking about the product, but you're thinking about everything that goes on behind the product and everything that goes on ahead that people experience directly to them. So you're finding a way to incorporate all these diverse perspectives into one design process, which becomes a challenge because you're not just talking about people along the value chain, which are discipline responsibles, but you're incorporating people outside of your own company as well, different stakeholders. So you have, say you have a municipality, you have also a construction company, you have an engine provider, you have an electronics company, you have a battery, you have many different people that are trying to come together and create an entirely new solution. So it creates this challenge of communicating together, and you need to have some way to facilitate and understand the concept that you're going towards. So what we've been working with and what we do in design fairly often is we utilize prototypes to convey a message and also to help explore these opportunities together. So when we talk about prototypes, a lot of people think that you'd say that this is a prototype. And yes, it is a prototype, but it's not the earliest version of prototyping. So you might think that this is the earliest version of prototyping. You go straight into CAD, you make it, and you're starting to make choices about this specific model itself. But in reality, in design, we come from as far early as possible. So you want to match the fidelity of your prototype to the questions you're trying to ask. And so you match the prototypes to the people and the situations and the questions that you need to get answers to. And specifically, we talk about when you're progressing along the prototyping chain, you're going to move from simple to complex, cheap to expensive. All these things are done so that in the earliest phases of design, you have the most availability of time of adjustments that can be made. So you want to make them when it's cheap and easy, like say it's cardboard and wood, versus when you've already spent hours putting into CAD or when you've already welded things together. I'd like to talk a little bit quickly about my motivation around this, and it tends to stem from a collaboration project I was on in my first year of my master's, working with BTH and Stanford, where we came up with, we were challenged and tasked with finding a way to create trust between humans and autonomous machines. And so we spent 9 months coming together and doing our need finding and prototyping, and we were surrounded by this concept of electrification and autonomous machines, and recognizing that, you know, when you're going to put a machine out there, it's not just going to be a direct replacement of something that people already have and people already understand. You're talking about changing an entire fundamental way that people get a job done. Like the overall solution is much different than the individual components that create it. So we were working with creating a communication system that was multi-tiered and enabled people to talk or understand what the intentions of the machine, autonomous machine, were going to be. And so that really drove me to want to continue to work around these autonomous machines and figure out how we can create them as a solution and not just consider them to be an individual replacement one for one. There we go. So within all of these things that we've just discussed here quickly, we run into this challenge of ambiguity, especially when you're talking about transformative solutions that are much different than what we're used to. Putting it into a PSS context, you have many diverse inputs that need to come into the fray, and also you are now opening up the opportunity space or solution space, and so you have 100% of your design availability is open, but at that time you know very little about how you're going to solve this problem. What are the actual solutions going to be? So you need to incorporate all these different people and bring the right people in at the right times early enough to provide you with directionality on your innovation. So coming up with concepts and feedback and all these things, you need to have everybody that's involved in the final solution value be involved as early as possible. And so that's where you get these diverse perspectives, which is a challenge, but it's a benefit. It's a necessity. It's a necessary evil for putting these things together. And then when you get to the final aspect of this problem that I'm talking about is you want to nudge people a bit, because if we're talking about transformative innovation as opposed to incremental, you need to provide your collaborators something that pushes them well outside of what they're used to seeing. So if you bring in someone that's an engine designer, you need to show them something very different than what they're going at as far as the solution is. You need to push people outside of their comfort zones to allow them the space to feel like, oh yeah, we can get a little crazy. We can solve this in a much different way than we have previously. So this led to my research questions, which the first primary one was, how do we now manage this ambiguity when you have these different people? You have all this open design space, and you need to navigate it. You need to start somewhere. You have plenty of unknown unknowns, and you need to find ways to turn these unknown unknowns into at least known unknowns, and eventually known knowns. So the follow-up part was, once I started doing a little bit of investigation, my path through this research was going to be looking at prototypes, because they are a primary vehicle when we talk about design thinking or the design approach to it involves a lot of using prototypes as these vehicles that we navigate the ambiguity process and design process through, because they serve as a vehicle that can give people a concrete item to give us feedback on, or help them understand what we're trying to achieve. So, come on, there we go. So the approach. So how did I go about answering these research questions? There we go. So I had the opportunity, in essence, to work alongside this electric demonstrator site that will be popping in and out here, I guess, with Volvo Construction. And it was a nice open challenge, because they're working with how do you, especially in this conservative industry of construction and traditional industry, how do you provoke people into being interested in something that is much different, and how do you touch on the values and convey those values? Because we're talking about, if you look over here on the bottom, traditional yellow machines, which they should be yellow, but it's very simple. You're maximizing the value and the productivity of each individual within that machine. You make the machines bigger, obviously, and then that's how you get it. But you wind up with a number of limitations. So we talk about moving towards this electric and autonomous construction site, where you have many more small machines, and you're taking advantage of different technologies in order to achieve a more continuous flow, because you're no longer limited by the individuals driving each machine, but you can optimize for the output of the site. So what the focus was to focus on the functional output of the site, which is, you want to, in this sense, it's a quarry, so you want to produce material. How do you produce material? With the lowest carbon emissions, and you want to completely change how you utilize energy. And so this was a very different, a very transformative style of solution than most construction quarries or sites are really used to. So when I wanted to pursue how to help engage these external stakeholders, customers, different parties within the larger corporation that is Volvo, and other entities that were involved in the process of either buying or being a co-creator with it, I needed to actually create this prototype, because this isn't something that exists in a standard protocol for how to explore PSF solutions. So I needed to actually create this prototype in order to explore these research questions the way that I wanted to. So it turned out to be this 5 meter by 5 meter site, and the machines are a 1 to 11 scale down versions, and they reflect the general scenarios that are going on the electric site that was just on the screen before. You have manual loading machines, and you have autonomous haulers that switch back and perform their tasks in a similar way to they would on the site, or at least when people are observing it and they haven't seen what else is going on, that's exactly how they experience it. They experience it in the same transformative way as you would if you potentially saw it. And the other reason we needed to build this was because at the time when I wanted to start with this sort of research, the machines only existed in maybe one or two of each in full scale and operation. So being able to work with them and work around them wasn't much of a possibility. So we'll get to that later. And then yeah, exactly. So I use that. I'll go back one actually. So I use this as the means to conduct my qualitative investigation. So all of the observations and the surveys and the interviews were done using this as the vehicle through which they were being communicated. So most everything was a reflection upon this or a reflection upon the site that it was supposed to be representing. There we go. And so we can get in finally now that we are down here at the scope of where I'm at, which is within these emerging technologies, trying to take advantage of as many of them as possible to create transformatively better solutions. You want to create a pure product service system to support these sort of solutions and get them out there. And what my vehicle was through prototyping to conduct this sort of collective assessment. And what happened on this first one, the first results don't reflect the actual interviews with the site. These were just interviews done with people across different stakeholder positions within the construction industry. So they were aimed at understanding, if this is the other view of prototypes, if I want to use other kinds of prototypes, what are the prototype views now? How do they perceive the use of prototypes? What are they? When do they use them? Why do they use them? And what do they actually look like? When do they come into the phases? And so what I noticed across the interviews was that they typically enter into the conversation much later in the stage, and when they do, they are more likely to be a semi-full scale or almost full, ready for production machine that's ready to go. So it's not really meant for learning, more as verifying certain qualities that you wanted to have in your machine. So it really highlighted the fact that there's a narrower view on what prototypes are for, and especially across these different stakeholders who are going to be service designers and product designers and innovation managers. So next one. So the second results were kind of the most interesting ones, because what happened was when I ran the site for the first time and introduced it to people, it wasn't that I was introducing the site. The purpose of utilizing the site here was purely to set the context for investigating a specific concept. So this harkens back a bit to my motivation, which was that communication system. And so here, finally 2 years later, we had made a augmented reality version of it, which was actually running on a HoloLens. And so we wanted to use the site to set the context around getting feedback about that specific concept. So we were trying to investigate these intangible interactions, where humans and the machines on this future site, in this future scenario, are going to have to interact, and how can we preemptively start solving some of these challenges. And so the site was an obvious step in being able to do that. While the majority of my results from this paper and these results was focused on whether or not people liked or what sort of feedback they could give me about the concept, the other results that were captured were whether or not the site actually functioned as the contextualized platform that I wanted it to. And the surprising thing was just how well and how positive the feedback was around that aspect. And so taking that was what drove me forward in the progress, is that I wanted to investigate that aspect more. And so we get to the third set of results, which was the next time I put the site on display, it was that the site was the prototype. The actual functioning site was the actual prototype of the product service system of this future scenario. So the surprising part was that it really got people to step out of their state of disbelief, suspend their disbelief of whether or not autonomy was the solution for construction or electrification was possible, and instead start asking questions like, okay, well, how many of these would it take to replace the one big hauler that I have, or how many charging points do I need, or where else could we incorporate this, or what other sort of machines can we actually put in between some of these machines, or now that we're designing machines specifically to be autonomous, what other things can we design differently if they're going to be autonomous? So it raised the level of discourse, especially around these customer co-creation conversations, to be much more tangible and looking forward as opposed to just observing and seeing it. So it enabled itself as a way that everybody could comprehend the same concept at the same time, which in the academic world we would discuss as a boundary object, because it was everybody that observed it could observe it the same way and understand the same concepts that was going to be conveyed in the same way. So when we get to the final conclusions here, it was the fact, the largest conclusion I would say was that the prototype system being tangible was the biggest change, in the sense that prototypes up to this time around product service systems primarily reflect diagrams and very two-dimensional representations. And so by bringing a system to life in a physical manner that people could see and interact with, changed the way that they interpreted the possibility of it. You could actually see moment to moment what's happening. What are these interactions? I can see the system happening. I can see the individual machines working. So they were able to really experience it the way that we experience the world temporally. Things happen in a sequence, and we need to understand what are those moments that are in between these sequences. So the fact that it was able to enable this level of understanding and discourse was probably the most interesting result for me. But the last part, I think, is the biggest one here, is that the implication being that when we look at all of these product service systems and you're trying to create innovative solutions, maybe the site isn't exactly the representation that every time you're going to do a product service system, you need to build a functional item thing that does, that's a 5 by 5 meter representation, and you spend a bunch of time on it. But when you get to scenarios in which when you're conducting this sort of step change and you're really trying to do something that's transformative, what we would call in pedagogy as a threshold concept, when you're trying to transition to something that's much different than what we're representing, then these sorts of things become highly valuable, because everybody can experience it and actually have productive input into the creation and the evolution of these concepts. So that's me. I'd like to acknowledge a lot of the people that were made this possible, be it my supervisors or my company sponsors and company collaborators that are up there, and girlfriend Erica by supporting me when I was not taking care of myself at times, and the KKS that's really helped make it possible with the funding and also all the stuff. That's what we have. Thank you very much for listening.